So here you will see the heat transfer analysis of a flat plate. We will take one rectangular plate, thin plate. So bottom side is at high temperature, like a heat sink of the system processor, CPU processor. So bottom side high temperature, all other sides are open atmosphere. So with that, how the heat transfer happens, that we can see. Again, first step, you can check the unit /unit, SI, so that you can fix the SI units. So in this window you can ensure, so you have to give length is in meter, force is Newton, temperature is in Kelvin. Okay, so SI unit is taken by giving that command. Then as usual, you have to change the directory first. I am changing that to the desktop, so directory is desktop now. Then file name you have to give, maybe heat transfer or a heat transfer of a flat plate I will give. And then we will come to the main menu. So preferences, either it is structural or thermal you have to define. So we are going to do the thermal analysis. So I am selecting the thermal. Then we will go for the pre-processing, that is designing and meshing. First you will choose the element type, add the element. So in the thermal mass, 3 options are there. Link, that is 1D, solid means both 2D and 3D, shell means 2.5D elements. So we will take the solid itself, which is both for 2D and 3D. So first one is for 2D. If you go this brick model and all, it is for 3D, like that, depends upon you can choose. So I am going to do a planar only, so I will take just solid first option. You can see plane 55, that is in the mechanical APDL element reference, you can see the difference between all those solid name etc and all. You can see solid 278, that link it is just 1D, if it is shell it is 2.5D, like that it will vary. This document you can check it, ANSYS element reference file, you can check it for better understanding of those elements. Okay, now I am taking just one plane. So element is defined, then I can define the material property. So go to the material model, thermal, conductivity, isotropic, which type of material, according to that you have to give the conductivity, thermal conductivity. If it is steel it is 45, if it is aluminum it is 235, like that you can give. Okay, I will take the just steel, 45 watts per meter Kelvin. So material is defined, just steel only. Then modeling, create. As I mentioned, I am taking the planar, so I have to create the area now. If you are taking the that is 3D, like a brick etc and all, you have to go for the volume, 3-dimensional means. This is just a 2D, so I am taking area only. Maybe I will define this rectangle using the first option, that is first I am taking 00 point, xy point. Then what is the width and height I can define. Maybe one side is 2 meter, another side is 2 meter or 3 meter, something you can take it. So this is the area, rectangular area I have created, plane. So once the model is done, you can go for the meshing. Again meshing also, you can go to the size control, manual size, then sizing you can define what is the division you need it, or otherwise the global sizing, like mesh tool, if you click there is a small size. By default you see, if you mesh on this is the mesh, coarse mesh. If you want you can slide this to the fine. For example for 3 I bring it. Now you mesh, now if you mesh, apply, remesh, see this much it is refined, but this is just a global refinement. You can keep on move this to the very fine. So okay, with this we will proceed. So meshing is done. Then loading. So I am going to take high temperature at the bottom, then all 3 sides will be open to the atmosphere. So define load, apply the load, thermal load, then in the temperature. Here also, as it is 2D plane, I am going to define the temperature in the line. If it is the 3D volume, you will apply the temperature in the area. So now I will define the temperature in the line. So this line is, assume it is on the processor. So processor temperature maximum it will go to 90, more than 90 also. So I will take around 370 Kelvin for that. Then all other sides, you can use shift to select all other sides. There I am applying, it is open to atmosphere, maybe just 300 Kelvin. Okay, so loads are defined here, high temperature, other three sides are low temperature. Then go to solution, solve current load step. Okay, it is done. Now we can check, go to the post processor, plot result, contour, nodal solution. We can check this nodal temperature. This is how the temperature varied.